Okay, we have started the recording over, so there's gonna be two parts. I accidentally pressed the stop button, so let's see. We are going to go on to question 16. Let's draw the organic products, so we're gonna go ahead and do that. We have the aldehyde, and we have this right here. So that's question 16. That's an enamine hydrolysis by HCl. I think we can get question 17 on this one. 17 says draw curved arrows. Remember, it's a good hydride, so it's gonna come in here like this. Good, it's a good source of hydrogen anions. Then what is step 2 says draw the charged organic intermediate. So let's just do that. So there's the intermediate. And step 3 says draw the final product. Well, it's going to pronate itself. There'll be a proton transfer. So part 3 is the proton transfer. This is to form the alcohol. This is the ketone reduction via sodium borohydride. So we're going to go on to 18. Just want to make sure that we're recording. Yeah, we are. So 18 says, use retrosynthetic analysis to suggest a way to synthesize diphenylmethanol using the Grignard reagent. Identify the aldehyde and the Grignard. So we're going to identify the aldehyde first. The aldehyde will be benzaldehyde. So we'll draw benzaldehyde. You don't have to draw it. You just have to select it. And then the Grignard reagent will be this right here. So this is part A. It'll just be a benzene. Oh, actually, I can draw it much easier like this, and it doesn't matter which side that goes on. So we'll have that. And that's it for question 18. So all you have to do is select A and B. We'll go on to question 19 now. Question 19 just wants us to add curved arrows. I'm just going to draw the ketone group because everything else, it will become relevant. But here we're going to have the cyano group. It's going to come in like here. There's other stuff coming off, but this is just my abbreviation until we have to put it in. And then step 2, because I don't think it's requiring you to draw, or you just have to put in the arrows. So we have this right here. That's be a proton transfer. And step 3, complete the structure. So we'll complete the structure in part 3. This 5-membered ring. potassium. Let's draw this here. We got this. This. So we have all the steps done then. Yeah, so everything's done. So that's question 19. All right, so question 20. This is a Wittig reaction, so we're going to form. Let me see if I can help direct you to a good page number for that. Look out. Wittig reactions start on page 877. We're basically just going to add a carbon-carbon bond. So, I think a good, if you look at mechanism 1913, that's going to be a good place to see where this is all coming at. So I'll put this in. This is a mechanism. Oh, it's not letting me write. Oh, let's just let it slow down. There we go. So this is mechanism, was it 19.31, 19.13. And if we just follow those directions, we're going to get this right here. Oh, and then here's your phenyl group. So we have that. And then kind of on the same thing for 21. Let's just draw this right here. So 21, it just wants the retrosynthesis of the Wittig product. So, we just have to think backwards on this one. We're going to have this. Or that 6-membered ring and the bromine coming off. Let me redraw that for you. The bromine coming off. And then we have the carbonyl starting group. So we have the aldehyde. So that's why they were so big on aldehydes and ketones, because a lot of these reactions use these functional groups. Oh, let's draw that. So now we've drawn the aldehyde functional group. You can put a hydrogen there if you want. That's the carbonyl starting group. So we had benzaldehyde in that cyclobromo group. So that'd be bromocyclohexane. So that is 21. 22, I'll stay right here with 22. They're going to start to talk about the Baer-Villager reaction. All right, so let's go to where are we at? We're going to go to 22. Somehow this is here. Okay, so draw the major and minor products of the Baer-Villager reaction. If you want to get a really good example of how the Baer-Villager works, please go to page 881. You can see the mechanism for the Baer-Villager reaction. We're going to take that ketone and we're going to create that ester. Okay, so we have a ketone. Let's go ahead and draw the major and minor products. So the major, and then we're going to draw the minor. Right, so we've done that. That's 22. So let's go on to some IR spectra. So this is 23. Is which peak corresponds to the indicated stretch? They're showing benzaldehyde and that hydrogen from a aromatic group off the benzaldehyde. So we are going to select peak A. We'll continue 24. These are short little answers, so we'll do just continue on the same slide. 24 says consider the IR spectra the unknown. Which compound matches the IR spectra the best? We're going to select compound F. And we see that carbonyl stretching at 1685. That's why we're selecting compound F. Okay, so we have that one done. Now we're going to go on to 25. I don't know why it does that. 25, how many unique proton, NMR, and carbon-13? So I have this compound. I don't know what, you may have a different compound. So, you're going to have a H1, an H2, an H3, and it'll repeat itself here. So you have 3 hydrogen signals. Let me see, 1, 2, 3, 4. So for carbon 1. So for carbon, you have 4. And let's see. Oh, they have more compounds. Oh. Just go ahead and just do that again. So compound B, this has 3 hydrogen signals. It has 4 carbon 13 signals, kind of like how we found it before. And compound C, oh, proton signals for compound C will be 2. And for carbon 13, there'll be 3. And for compound D, oh, I knew I was going to do that because compound D will have proton will be 3 and our carbon will be 4. All right, so that gets us 25 done. All right, so let's go on to 26 then. 26, they just want us to, I think they just want us to draw the structure. They give us some molecular formula. So we'll go ahead and draw the structure. We have a ketone with a tert butyl group on it. '27, they want us to draw product A and product B. Well, first we're going to have a ring opening for product A, right? Here's your ring opening step because you had an epoxide. And then we're going to have the toluene-Dean-Stark apparatus for product B. So let me think about that one. So we're going to form our acetyl group. So then for product, oh, I knew I was going to do that. So B, we're going to form our acetyl. And that should get you product B. And we only have one more, and then I think we're going to be done today. We've done a lot today, so congratulations on making it through the study of aldehydes and ketones. This was a lot. And then to find out how to do question 28, I'll show you where to go. If you go to page 887, that's going to give you all the mechanisms, synthetically useful reactions. So R1 is going to be BH3 and THF. R2 will be this. R3 will be PCC. Step 1 is the hydroboration. It inserts a BH2 on the primary carbon atom. Step 3 is the oxidation. Step 2 is the oxidation of organoborane. Step 3 oxidizes the primary alcohol to an aldehyde, so you're going to use PCC. And step 4, the aldehyde reacts with the primary amine to form an imine. So R4 is this right here. Let me rewrite that. That's it. So congratulations on making it through the study of aldehydes and ketones. That's it. If you have any questions, you can please stay back. Otherwise, I'll see you tomorrow.